Good morning. My name is Megan Edwards of Focused Communications, and today we're getting the latest from Eloro Resources, which trades on the TSX.V exchange under the symbol ELO. Joining me is Eloro's Executive VP of Exploration, Dr. Bill Pearson. Bill, thanks for coming on today.
Oh, my pleasure. Always good to chat, and whenever I get to talk to you, it means we've got more good news to tell our shareholders, which is always great.
Yes, that's always a good thing. Before we jump into the latest news from Eloro, could you briefly overview the Iska Iska project and the size of the system?
Yeah, absolutely. Of course, I'm giving you some forward-looking statements, so the usual cautionary language. So as many of you have been following us, we've had a very, very major focus in our Santa Barbara deposit area. We've completed about 85,000 meters of drilling in 122 holes. And that's essentially drilled over a strike length of almost 2 kilometers here. We've more recently been focused on this sort of core area in the center here, where we've had some really, really excellent drill results. And you can see here at the center of the caldera here, what we found is that we actually have a very major dacitic porphyry there, which is driving this whole porphyry epithermal complex. So right now we're moving ahead on doing our first inaugural mineral resource estimate for Santa Barbara. That work is progressing well and is targeted for the end of Q1 20 of this year. So we essentially, where we sit in Eloro right now is we have one world-class silver, zinc, lead, tin deposit kind of in the bank here. The dimensions are very impressive. Our higher grade core is about 1,000 meters along strike, 800 meters wide, goes to a depth of 1,100 meters. So that will be certainly the core of our potential resource. But what our release that we just put out this week shows you is there is another really tantalizing target here, which we've talked about conceptually for some time, but we now, with all our geophysical work, now can start really talking more specifically about actual targets. So this is a plan map of what's called the analytical signal, and you'll see here we've got this dashed line around here. This is outlining this huge area which has very high magnetic response. And you'll see here up in the north part here, if I just use my up in this area here, that's basically where the caldera that I was talking about is. And you'll notice a lot of this is green. It's very low magnetically. But outside, when we look at going outside, you can see the red coming around here, down here, and then there's a big, huge area down in the south and the Casiterita, which is all red. Well, this is clearly a very major magnetic intrusive. Now, it's important to recognize there's only 2 magnetic minerals. One is magnetite and the other one is pyrrhotite. We're in an environment where we have a lot of sulfides, so clearly we're not dealing with magnetite. This is reflecting pyrrhotite, and pyrrhotite is the sulfide that ends up forming when you form a tin deposit. And tin is very unusual geologically. It forms as a high temperature mineral, about 300 to 400 degrees C, and it's very deep. And the crust in Bolivia is about 80 kilometers thick. So this whole magma here, that formed this huge intrusion, started off quite deep in the Earth's crust, and eventually came up here to form this huge intrusive complex that's about 5 kilometers by 3 kilometers. Now, you might ask, well, how does this caldera fit into it? Well, if I can take you back maybe to 12 to 14 million years ago in southern Bolivia, you had a massive volcanic series of eruptions. And so this huge intrusion you're looking at, this likely tin porphyry, this formed a massive stratovolcano here in Iska Iska. And what happens with stratovolcanoes is you build up a huge cone, and I think many of your readers have probably seen pictures of it, of these kind of volcanoes. And what happens, eventually the magma chamber empties, and you have a big void down there, and the whole thing becomes unstable and it collapses. And that's how you get a caldera. Well, what happens is that after that collapse, the pressure builds up again, and you get a second stage of major volcanic activity. But instead of building a stratovolcano, what happens is it comes up as breccia pipes, as domes, and this very major porphyry epithermal silver, zinc, lead mineralization stage. So what you have here is 2 major systems. You have an early, deeper tin system, and then superimposed on this is a later major porphyry epithermal silver, zinc, and lead. And it's very interesting when we look at the metal distribution here. Where we find tin, we have no zinc. Where we find zinc, we have no tin. Where we find copper, we have no zinc. And and that's telling you that these are 2 discrete major mineralizing stages. So in terms of our evolution of our thinking here and our exploration, Santa Barbara is in the bank. I mean, we got 85 holes in it. 85,000 meters of drilling, 122 holes. We have still not missed on one hole in this deposit, and it clearly needs more drilling to fully define, but we have more than enough extent to define a very, very good maiden resource. So that's kind of in the bank. So where our focus now, and the reason we did that financing, is to go after the big tin porphyry. And that really brings me to the next slide to say, well, what are we exploring? I mean, you got this huge area. We can't drill everywhere. What are we focusing on?
I was going to say, Bill, yesterday the company announced results from an IP survey completed on the recently acquired Casiterita property. Could you run us through the details of this release?
Yeah, absolutely. Just quickly showing you this section. You can see how continuous this magnetic anomaly. The high spots down there are very likely part of the tin system. And again, you can see where our Santa Barbara deposit. So yeah, let's look at the IP. Very, very interesting results here. So this map is a plan map. We've got 2 IP models here. The one at the top here in that area is Santa Barbara, down deeper down in Santa Barbara. That's a 3D conductivity model from our borehole data. And then down here in Casiterita, we have a plan map, which is our recent surface IP, showing this very, very extensive conductivity anomaly. And over here on the left here is a section. You can see this red area here. That's highly conductive, and it goes really right up to the surface. It doesn't take much imagination to see that, well, if you go down here, guess what? This is continuing on. So we also had some very, very interesting channel sampling results we released some time ago in the Porco added 103 meters of 117 grams silver, some gold and copper, but 0.66 tin, no lead and zinc. And if you go over 800 meters to the east to Mina Uno, Mina Dos, that we put out couple of weeks ago, you have silver, zinc, lead, and tin. So you're still getting the epithermal overprint over on this side, but in the Porco, you're clearly into more of the tin system. So we've set up, we're drilling now, we're testing across this anomaly. We've just finished off our permitting process to drill in Casiterita, so we'll be doing some holes over here. And what this anomaly is when you look at Bolivian tin deposits, you typically have a low-grade pyrite halo around these things, which obviously with pyrite is going to be highly conductive, and especially if you have pyrrhotite. So what we think is that we're probably picking up a pyrite halo, and once we get through that, we got a very, very major chance of going into a tin porphyry. The other piece of evidence we have is there's quite a few artisanal tin workings dating from the 1960s on Casiterita. They produced about just under 70 tons of tin concentrate grading about 50% tin, and there's artisanal workings dotted around here right over in the area of these anomalies. So this is a really, really exciting target. The other thing is on the west side of Santa Barbara, we have lots of tin. Well, those intersections are in the northern extension, the highest level part of the tin system. How do we know it's the highest level? Because look at the copper distribution. Most tin mines start out as copper mines, and then you go into tin. San Rafael in southern Peru is like that. If you follow the historic mining in Cornwall, it started out as copper mining, and then they discovered tin below it. So that's very typical of tin systems. Well, if we look at our best copper intercepts, well, they're right up in the north end here. And when you look at the distribution of copper versus zinc, tin versus zinc, guess what? Where you have tin, you have no zinc. Where you have copper, you have no zinc. So this entire system runs down here as the magnetics indicate. But the nice thing down here, our problem up in Santa Barbara, we got a kilometer mountain sitting on this tin porphyry. So when we look at our deep drill holes down to 1,000 meters, guess what? Near the end of it, we go into tin. And our other holes to the south have been kind of on the margins of it, just clipped it. So we've got a shot here at a tremendous target here without a kilometer thick mountain on top of us. Because here we're relatively near this anomaly. The IP survey will see down about 200 meters. So we have an amazing opportunity here at Iska Iska. We already have one world-class silver, zinc, lead, tin polymetallic deposit in the bank. We're doing an MRE. We're targeting end of Q1. That's well on track.
And now, in previous interviews, we had always discussed the underlying IP tin porphyry at depth. Based off of early interpretation, would this new target at Casiterita be closer to surface?
Absolutely. Yes. It's very close to surface. As you can see from the profile, the anomaly actually comes right up to surface. And we probably are seeing down about 200 meters in our IP profile. So that's the difference, where in Santa Barbara, I got to drill 1,000-meter hole to get into the start of the tin system. Here, I'm much, much closer to it. So, and that was one of the big reasons we really were keen to pick up Casiterita. It took a little time to do the deal, but we got it done. So essentially, we have a shot at finding a second world-class deposit here, which will be primarily tin, in addition to what we've already outlined, which is extraordinary. And plus, look at the scale of this system. I mean, 5 by 3 kilometers. It's huge. So that's why that release on Tuesday was a very significant one. We've been continually building and improving and refining our model. So we now have some really, really nice targets to test. So, fingers and toes crossed, going to be a very, very interesting next 3 to 6 months in Eloro.
Before we let you go, is there anything else that you'd like to leave with our listeners in terms of the next steps here with Eloro?
Well, clearly in the short term, end of Q1, we'll be looking to get that MRE out. I'm working very closely with Micon on that. So that will be a signature event. We've already started drilling, as we have announced, on our target. We've got some initial drilling in the Porco Mina Dos area, and then we have our drilling permits to move over into Casiterita. So we'll have results of that drilling. So there's going to be a lot of, I hope, very good news. And if we can nail down this tin porphyry as we believe is there, this will be, I think, a huge game changer for Eloro, because we have one terrific deposit in the bank, so to speak. If we can outline a second, that's remarkable. I think it's very, very possible, but the drill bit will tell the story.
Well, thank you so much for your time today, Bill. Keep up the good work at Iska Iska, and we are excited about what the company finds next.
Always a pleasure. Look forward to our next chat. As we've always had good news to chat about, so I hope to keep that trend going forward. Many thanks.
Thank you.